I will introduce you to our first speaker, Dr. Kaitlyn Lawrence. Dr. Lawrence received her PhD in Environmental Health Sciences from Tulane in 2018. Her dissertation focused on studying the lung health of response and cleanup workers following Deepwater Horizon. Kaitlyn received multiple awards in recognition of her work, including a runner-up prize for Best Paper of the Year in the journal Epidemiology. She currently works as a postdoc fellow under Dr. Dale Sandler at the National Institutes of Environmental Health Sciences, where she continues her research to better understand potential human health effects following oil spills. Now, I asked each of our speakers today to give me one little tidbit about themselves of how they've been spending their time in alleviating boredom during stay-at-home orders. So Kaitlyn has been enjoying learning how to grow vegetables, and she's been having great success with both tomatoes and radishes. And with that, I'll turn it over to Kaitlyn.
Thank you for that introduction, Missy, and thank you for inviting me to speak with you all today. I will be presenting some of my research assessing lung function responders following the 2010 Deepwater Horizon disaster. The unprecedented Deepwater Horizon disaster response effort comprised tens of thousands of cleanup workers and thousands of sea vessels. During the cleanup period, workers were exposed to known and suspected respiratory irritants, including volatile organic compounds found in crude oil, as well as combustion byproducts from flaring natural gas at the wellhead and controlled surface burns. Prior human health studies have identified adverse respiratory health outcomes in cleanup workers of other oil spills, such as higher prevalence of lower respiratory tract symptoms and increased levels of markers of airway inflammation. Few studies, however, have examined measured lung function, and those existing studies have had some methodologic limitations, including small sample sizes and limited exposure metrics. Further, no prior studies have focused on the Deepwater Horizon oil spill, which has unique exposures, presenting an important knowledge gap. So given this gap in our research, in the literature research, our research objective was to determine the relationship, between oil spill response and cleanup work exposures and lung function. Today, I will be presenting results from two of our studies assessing responders' lung function first 1 to 3 years after the Deepwater Horizon disaster, and then 4 to 6 years after the disaster. The Gulf Long-Term Follow-Up Study is a large prospective cohort of oil spill cleanup workers and non-workers following the Deepwater Horizon disaster, led by Dr. Dale Sandler at the National Institute of Environmental Health Sciences. The cohort enrolled 32,608 participants from across the United States. 11,193 enrolled participants who were living in the Gulf states completed a home visit examination, and about 3,400 living within 60 miles of two clinical sites in Mobile, Alabama, and New Orleans, Louisiana, completed a clinic exam. And I'm just showing here the map of our enrolled participants across the US, and I zoomed in on those two clinic exam locations and where our participants live. So following the Deepwater Horizon disaster, Gulf study investigators started enrolling participants in March 2011. And since then, investigators have periodically followed the cohort over time. In addition to answering questionnaires, participants provided lung function measures at the home visit, as I mentioned, 1 to 3 years after the spill, and again at the clinic exam 4 to 6 years after the spill. Lung function is a really important indicator of general health and is typically measured using spirometry. The primary outcomes of interest include the forced expiratory volume in 1 second, or the FEV1, and the forced vital capacity, or FVC. We conducted spirometry following standard guidelines put forth by the American Thoracic Society and European Respiratory Society. We measured lung function using a portable ultrasonic spirometer at each visit, and tests were independently reviewed for quality by an expert. Oil spill histories were collected at the time of enrollment. Industrial hygienists used this information and classified workers into job classes by qualitative assessment of the degree of total hydrocarbon exposure, with response work classified as the highest exposed and support work as the lowest exposed. Industrial hygienists additionally classified workers based on burning and flaring activities as a surrogate of exposure to PM 2.5 or fine particulate matter. Participants were classified as high if they worked on a vessel at the wellhead, medium if they worked on a vessel proximal to the wellhead, low if they worked on a vessel that burned oil on water, or unexposed if they didn't fall into the above categories. In the first study, we analyzed data from 7,775 home visit participants who completed the first spirometry measurement 1 to 3 years after the spill. As I mentioned before, these participants came from one of each of the 5 Gulf states, and the reason why our number jumped from 11,000 to 7,000 was mostly because a lot of our participants didn't achieve spirometry quality. In the second study, we analyzed data from a subgroup of participants, totaling about 1,840 participants who completed a second spirometry 4 to 6 years after the spill. And again, as a reminder, these participants were a subgroup who lived close to clinical sites. For our statistical analysis in study 1, we used multivariable linear regression to estimate cross-sectional mean differences and 95% confidence intervals in lung function at the home visit. For study 2, we used multivariable linear mixed models to assess both the cross-sectional lung function measured at the clinical exam, as well as changes in lung function between the 2 visits. This second study was conducted again in an eligible subset of participants who completed 2 tests, and all of our models controlled for the potential confounders listed here. Before I explain to you our results, I just want to orient you to some of my graphs. On the y-axis, we can see the exposure of interest, whereas on the x-axis, we can see a particular lung function measure magnitude in milliliters. Estimates that fall on the left side of the graph indicate lower lung function, and thus on the right side indicate higher lung function. And if the 95% confidence interval, seen as the error bars here, contains the null value of 0, the estimates are not considered statistically significant. So I'll get into the results. 1 to 3 years after the disaster, we observed no overall differences between workers and non-workers. However, among workers, those who conducted decontamination work had reduced forced expiratory volume in 1 second on the order of about 71 milliliters and suggestively reduced forced vital capacity. This work involved high pressure spraying, and our observed reductions in lung function may be attributable to aerosolized chemicals due to the nature of this work or the potential presence of cleaners that were not accounted for in our analysis. In addition, we also observed that potential high exposure to burning oil and gas was associated with a reduced forced expiratory volume in 1 second on the order of about 183 milliliters, and again, a suggestively lower forced vital capacity. This association is consistent with findings from smoking and air pollution studies that have also found similar inverse associations between particulate matter and lung function. The results for study 2 show that cross-sectional analyses 4 to 6 years later found no clear differences in our eligible smaller subset of participants. This was true for both job classes, which are shown on the left panel, and potential exposure to burning oil and gas as seen on the right panel. Although these differences were not clear 1 to 3 years later in this sample, it is important to remember that the sample size here is smaller than in study 1, potentially reducing our ability to detect differences in lung function, and suggested declines in lung function were still present. Further, the results of burning were actually suggestively stronger in this smaller sample compared to study 1, even though they did not reach traditional thresholds of statistical significance. So in the analysis of lung function between visits, noted in red, we did not observe clear associations that reached traditional levels of statistical significance, but results suggested that higher exposed workers showed greater improvement over time. These results may reflect recovery back to an initial health status, as those most highly exposed were likely healthier before the spill. Results, though not shown here for the forced vital capacity, were also similar to the forced expiratory volume that you can see. Our findings are again consistent with prior literature, particularly a study on the prestige oil spill cleanup workers, in which investigators found no persistent lung function effects further away from this in time from the spill. So the most important strengths of our study, this is the largest cohort that has ever been conducted to assess oil spill cleanup work exposures in relation to lung function. For spirometry of measures of lung function, this is a clinically useful measure that's widely used across the literature, and we were able to obtain measures over time. Our exposure metrics, as I mentioned before, capture information from different exposure sources and are therefore more specific than prior literature. Some limitations to take into account when interpreting our data include the fact that we may have a potential healthy worker effect, such that those who were selected or hired to work in higher skilled jobs may have been more healthy at baseline. We addressed this by restricting our analyses after comparing non-workers to workers, just to among workers to see if there were differences in those groups. For our spirometry measures, unfortunately, we didn't have any baseline measures of lung function. Of course, this was a disaster, so we came in after the spill occurred, but that limits our ability to make causal inferences. And there may be potential measurement differences in the home visit and spirometry that we can't account for just because the home setting is very different than a clinical setting. And then finally, our exposure metrics are ordinal at this point, and they may have some misclassification. However, we're excited to include more time-weighted and chemical-specific exposures in our future directions, as well as model potential effects of mixtures as oil spill cleanup workers were exposed to a mix of different chemicals. We also are interested in examining other factors, including community level socioeconomic factors and ambient air pollution. We know that participants living in this region may have more vulnerability to disasters. And so we're really interested in looking at measures beyond just the chemicals of the oil spill. Further, we'd like to expand on our research on respiratory health outcomes to include asthma, COPD, and the study in general is looking at many other endpoints in the future. So I'd just like to briefly acknowledge the PI and my mentor of the study, Dr. Dale Sandler, and the rest of the PIs, Dr. Lawrence Ingle and Richard Kwok, and our industrial hygienists. And I'd like to mention that my funding comes from the National Institute of Environmental Health Sciences. And if you have if you need any more information, please visit our Gulf Study website or feel free to reach out and contact us. Thank you.